So we're actually going to go back and finish chapter 5 by solving systems of 3 equations. We've done 2 many times, and we've learned the elimination method. And now we're going to move on to 3, which also can use the elimination method. We're just going to do it a couple times. And I'm only going to do 2 problems, and then there's 2 problems in the back, and that'll be left for you to do. So how are we going to solve a system of 3 equations? Well, we just have to make sure we eliminate one of the variables, and then we're going to have to go back through and do it again, so that way we actually go back to what we're used to, seeing 2 equations with 2 variables. So what I'm going to do first is I'm just going to pick 2 equations, and specifically I'm going to pick the first 2, these 2 here. I'm going to add them vertically, because if you notice, there's a negative z here, and then a positive z here, so they will cancel out immediately. So if I do that, I have 1x plus 2x, which is 3x, and 2 plus negative 3 is minus 1y, or negative 1y. Z's are gone, and then 2 plus a negative 1 is 1. So now we're more familiar with looking at something like this. But we have an equation with 2 variables, and we can't do anything with that, at least not yet. So we're going to hold on to that, and I'm going to go back to the original 3. And I need to get another equation that has just x and y in it and no z. So I'm going to use the bottom 2 equations. So I'm actually reusing the second one again. So if I use the bottom 2, and if I want to get rid of the z's again, I'm going to have to multiply the top equation, well, the middle one, I guess, this one here, by 2. And that will give me a positive 2, which will cancel with the negative 2 in the bottom. So I'm just going to write the new equation underneath this one. So that would be 4x minus 6y, and then 2 times z, where we get our positive 2z, equals 2 times negative 1, negative 2. So I just rewrote that one. Now I can add them vertically. So I get 9x, put these 2 together. Negative 1 minus 6 is negative 7y. And then the z's cancel again, and then we get negative 5. So now we have 2 equations, these 2 specifically, that just have x and y. So now we know how to solve this. 9x minus 7y equals negative 5. Line them up. Got to make sure we cancel something out here. I will multiply the top equation by a, let's get rid of the y's maybe. I'll multiply by a negative 7. That way it becomes a positive 7 up top and negative 7 on the bottom. So my new equation will be negative 21x plus 7y equals negative 7. The bottom one stays the same, 9x minus 7y equals negative 5. Now we can add these vertically. 21 minus 9 would be negative 12x. These 2 cancel, equals negative 7 minus 5, negative 12. Divide both sides by negative 12. And magically, we get a nice whole answer of 1. Now we have to work our way back through to get the other 2. Okay, so let's do that. We know x is 1, so I can go back to these original 2 here that we found in the middle and plug in 1 for x. So I will do that to the top equation. So I'm going to move this one and put it down here to this equation up here. So it's 3 times 1 minus 1y equals 1. All right, so we get 3 minus 1y equals 1, minus 3 on both sides. We get negative 1y equals 1 minus 3 is negative 2. Divide by negative 1. That just changes it to a positive 2. One last variable to do, and now we go back to the originals. Since we know x and y, we plug it into one of these originals. I think I'm going to do the very top one, so I'm going to put this one over here. Plugging in x, so it would be 1 plus 2. Our y value was also 2 as well. Minus z, we don't know, equals 2. 2 times 2 is 4. Add the 1, so you get 5. Put them together. Minus z equals 2. Oh. Now we have minus 5 on both sides. So we get negative z equals 2 minus 5, which is negative 3, and we'll divide by a negative 1. So z equals 3. So as a final answer, putting them all together, it's 1, 2, and 3. So just to recap, we have to go back through and do elimination, but I had to do it twice. I had to do it with the first two equations right here, if you remember that, and then I did it for the middle and the last one. So I just reused the second equation. Then once I got two equations with just x and y, we already know how to do that. Once we do that, then we go back through and find the other variables. I'm going to do one more. So let's see, what do we want to get rid of here? If you look here immediately, we see that we have a positive 2y and negative 2y. Let's put these two together and get rid of the y's. So I'm going to add these vertically. So that would be 5x. The y's cancel. And then negative 1 plus 4 would be a plus 3z. Then add these, 1 minus 2, which is negative 1. All right, so now we have an equation with x and z. We need another one with x and z. So how do we do that? Let's put these two together, the middle and the last again. However, to get rid of the y's, how are we going to do that? We have to multiply. All right, this is a negative 2, so we need to make the bottom one a positive 2. The only way to do that would be to multiply by 4, because half of 4 would be 2. So I'm going to multiply the bottom equation by 4. And I'll probably just have to rewrite the middle one again. So I'm going to put that over here. So we have 2x minus 2y. This one's staying the same. Plus 4z equals negative 2. The bottom one will be 4 times negative x, which is negative 4x. Then we have plus 2y, which is what we wanted, minus 4z equals 4 times 0, which is 0. Add these vertically. We get negative 2x. The y's cancels like we wanted to. And actually, look what happens here. The z's also cancel. And then we have negative 2 plus 0, which is negative 2. So divide both sides by negative 2. So in this case, we actually just get an answer for one of our variables right away. Just x equals 1. So we actually didn't have to do it. It's actually a little easier because both these variables canceled and we didn't even realize what was going to happen. So now that we know x is 1, we can plug that back into this equation and get z, and then we'll plug it back into one of the originals to get y. So I'll rewrite this. 5 times 1 plus 3z equals negative 1. So this is 5. 5 plus 3z equals negative 1. I'm going to minus 5 on both sides. So we get 3z equals negative 6 divided by 3. So z value is negative 2. Now we can plug both of these back into one of the originals. I will choose, why not the first one again? So I'm going to choose this one here. See if I have enough room. You need a decent amount of room for these problems. So 3 times x, which is 1, plus 2 times y, we don't know that one, minus z, which is negative 2, equals 1. All right, this is 3 plus 2y. Negative times a negative is positive, so it's 2 equals 1. 3 and 2 together gives us 5 plus 2y equals 1. Minus 5 on both sides. So 2y equals negative 4. Divide both sides by 2. Oh, y is also a negative 2. So as a final answer, we get 1, negative 2, negative 2. X, y, and z. That's how the order I'm doing it. X, y, then z. So that's 2 examples on how to do them. And then there's 2 more on the back to do on the other page. And then this whole thing will be complete and to be turned in.